Hello everyone, welcome to Neso Academy. We are implementing combinational circuits using VHDL, and in the previous lecture we have implemented the full adder and we saw that how it overcomes the limitation of the half adder by accepting the input carry from the previous stage. And today we are implementing one of the most fundamental subtraction circuits, the half-subtractor. So, in this lecture, we will first understand what is a half-subtractor, then we will implement it using VHDL. So, our today's topic is half-subtractor implementation using VHDL. Now, just like a half adder adds only two single bit inputs without considering the input carry, similarly, a half subtractor subtracts only two single bit inputs without considering the input borrow. Therefore, a half subtractor is a combinational circuit used to subtract one binary bit from another binary bit. So, half subtractor is a combinational circuit just like the half adder, which is used to subtract one binary bit from another binary bit. Now, half subtractor is a combinational circuit, which means its outputs, difference and borrow entirely depends on the two numbers that we are subtracting. And just like I said, half subtractor generates two outputs, difference and borrow. Here I am representing the output difference with diff. Now difference is the result of subtraction and borrow is borrow generated during subtraction. Let's understand this using one simple example. Suppose I want to subtract 1 from 0, which means 0 minus 1. Here 1 is a larger number. Now, can we subtract a larger number from a smaller number directly? No. Just like in decimal subtraction, we need to take borrow. In binary subtraction also, we need to take borrow from the next stage. Now, after taking borrow, this 0 will become 1, 0. Now, 1, 0 in binary is equal to 2 in decimal. So, this subtraction will be 2 minus 1 and the output will be 1. So, here the difference is equal to 1 and also the borrow is equal to 1. So, I hope you understand what are difference and borrow. Now, let's write the truth table for this half subtractor. Here we are having the two inputs A and B. So, here we want to subtract input B from input A. And this subtraction generates two outputs, difference and borrow. Since we are having two inputs, we will have four input combinations 0, 0, 0, 1, 1, 0, 1, 1. Now, let us verify the outputs. The first subtraction is 0 minus 0. Now, 0 minus 0 will give difference 0 and borrow will be 0. Now, the second subtraction 0 minus 1. The same example that I've already explained. So, here we are subtracting a larger number from a smaller number, which means we need to take a borrow. So, borrow will be 1 and after taking borrow, this 0 will become 2. So, 2 minus 1 will give difference 1. So, here we are getting difference as 1 and borrow as 1. Now, the third subtraction 1 minus 0. So, here we are subtracting a smaller number from a larger number. So, there is no need to take any borrow. Therefore, the borrow will be 0. 1 minus 0 will give difference as 1. Now, the last subtraction 1 minus 1. In this case, both difference and borrow will be 0. So, I hope you understand the truth table of the half subtractor. Now look at the rows where difference is equal to 1. Here, difference is equal to 1 when A is 0 and B is 1, or when A is 1 and B is 0, which means difference is equal to A complement and B, or A and B complement, which is an XOR operation. So, output difference is equal to A XOR B. Now, for borrow, look at the row where borrow is equal to 1. Here, borrow is equal to 1 only for this row. When A is 0 and B is 1, which means borrow is equal to A complement and B. So here we are getting difference as A XOR B and borrow as A complement and B. Now using these two expressions, we can easily construct the logic diagram for the half subtractor. In this logic diagram, we are having one XOR gate, and the output of this XOR gate is A XOR B, which is our difference. Then we are having one NOT gate, which is generating A complement. Then one AND gate, which is performing A complement and B, which is our borrow. So, I hope you understand the logic diagram of the half subtractor. Now, since we have derived the Boolean expressions, which means data flow modeling is the most suitable choice for the implementation of this half subtractor. So, let's go to my laptop and implement this half subtractor in Vivado using data flow modeling. So, we are in Vivado's code editor, and I am starting the code with IEEE library declaration by importing IEEE library along with the standard logic 1164 package from the IEEE library. After library declaration, we have the entity block. And here I am naming the entity as half_subtractor because we are implementing half subtractor. Is port. Now inside the port declaration, I have declared all the two inputs and all the two outputs of the half subtractor. So the two inputs A and B and the two outputs difference and borrow, and all of them are of standard logic data type. After port declaration, we can end this entity with the keyword end and the name of the entity half_subtractor. After entity declaration, we have the architecture block, and here I have named this architecture as data flow because we are using data flow modeling code of the entity half subtractor is. Now inside the architecture, after the keyword begin, I will write the Boolean expressions for difference and borrow. Now what is the Boolean expression for difference? Difference is equal to A XOR B. Now what about borrow? The Boolean expression of borrow is A complement and B. So I will directly write these two Boolean expressions inside the architecture after the keyword begin. So here I will write difference is assigned A space XOR space B semicolon to end the statement. Now in the next line I will write the Boolean expression for the output borrow. In that, first I will take the complement of A, then we will perform the AND operation. So in the next line I will write borrow is assigned inside the parenthesis. First I will take A complement with the help of NOT operator. So I will write NOT A. Then we will perform the AND operation and B semicolon to end the statement. So these are the two Boolean expressions for the half subtractor, and I hope you understand the data flow modeling code of it. Now first let me save this project and let's see the schematic diagram generated by Vivado for this code. For that, go to RTL analysis, click on Open Elaborated Design and click on Schematic. Now this will take some time, just wait for a few seconds. So, this is our schematic diagram generated by Vivado for the data flow modeling code that we have written. On the left hand side, we have the two inputs A and B, and on the right hand side, we have our two outputs difference and borrow. And here we can clearly see the output of this XOR gate is A XOR B, which is our difference. And this bubble is representing the A complement. So, the output of this AND gate is A complement and B, which is our output borrow. So, here we can clearly see that Vivado has converted the Boolean expressions into the logic diagram. So, I hope you understand the schematic diagram generated by Vivado. Now, let's see the simulation waveforms. For that, go to Simulation, click Run Simulation and select Run Behavioral Simulation. Now, simulation waveforms will verify our VHDL code. So, this is our simulation waveform window. Here we are having the two inputs A, B and the two outputs difference and borrow. Let me quickly assign all four input combinations so we can verify our VHDL code using force constant. So, here I have assigned all four input combinations and waveforms are generated. Let me maximize them. Let me zoom in further for better visibility. Now, this waveform is for input A. This waveform is for input B. This waveform is for output difference and this waveform is for output borrow. Now look at this instance 0 minus 0 and here we are getting difference as 0 and borrow as 0, which is correct. Now look at this difference 0 minus 1. So here we are subtracting a larger number from a smaller number. In that case, we need a borrow. And here we are getting borrow as 1 and after taking borrow, we are getting difference as 1, which is absolutely correct. Now look at the next instance 1 minus 0. For this, difference is 1 and borrow is 0, which is correct. In the last subtraction, 1 minus 1, difference is 0 and borrow is also 0, which is correct. So, I hope you understand the data flow modeling code for the half-subtractor along with the schematic and the simulation waveforms. So, we are done with the half-subtractor and its implementation using data flow modeling in Vivado. With that, we are done with the topic of half-subtractor using VHDL, which means we are done with this lecture. I will see you in the next one. Thank you.